First of all, sorry for being late. It was because of this. Something I was trying to do, I couldn't do it. I wasted my time. We'll get around to it. Anyways, we are going through the topic of calculating the earthwork. You are waiting for me to get this stuff. There's another princess coming who saw me and went the other direction. Huh? No, another one, not you.
Our princess.
Yes. Yeah, this is what I tell my daughters as well. There are lots of them. Okay. So last time what we saw was how to calculate the ordinates of the mass haul diagram. We talked about the balance points, and we talked about the concept of overhaul payment and free haul distance. So if you have two ordinates on the mass haul diagram which have the same value, okay, then the contractor can deposit material from here to here without any extra payment. So anything which is more than that will have some payment for hauling. Hauling means for transporting the material. Okay, so the point where we reached was this one. Yeah. See? Huh? Yes. Okay. So in this project, the same diagram which we have seen in this project, the contractor has agreed to a free haul distance of 500 feet, 5 stations. 500 feet is 5 stations. And after that, for every extra cubic yard of material transferred for every station, he will charge $11. Okay. So $11 for every cubic yard transferred for one station. Okay, per cubic yard per station. But if I have to calculate the total cost, I'll take 11 multiply by what? Stations, right? Why are you saying? No, come on. Go ahead. Yeah, so he will multiply by stations, and what else? Look at the rate. Okay, so it's 11 per what? Cubic yards as well. Okay, so you have to multiply with the stations and you have to multiply with the quantity as well. Okay, because he is charging according to two items, right? Per cubic yard material per station. Okay, so if it was only 1 cubic yard transferred to only one station, he will charge only $11. But if you keep the cubic yard same, increase the number of stations, he will charge you more, right? And if you keep the station same and increase cubic yard, again he will charge you more, right? His rate is increasing per unit material as well as per unit distance as well. Got it? Okay, so I need two things to calculate the total cost. I need the material, I need the distance. Okay, I need the material he will transfer and I need the distance to which he will transfer. Okay, now this is my mass haul diagram. His distance, free haul distance is 500 feet, 5 stations. Okay, I told you last time you cannot take it from the table. You cannot calculate this 500 feet. Okay, because it has to be on the curve. Both the points must be on the curve. They cannot be outside the curve. Okay, so only from the curve I can know where is the 500 feet which joins the curve. Okay, so we already did that. One is J, the other one is K. And then we have on the top one is S, the other one is T. Okay. So the station for S and T are given. So we will do the calculations according to that. If you go to the highway book, you will see the station for J and K as well. So you can do the practice in the same way for these two stations. Okay, so we are only calculating it for one part of the diagram. Okay, we have another part as well, and I mentioned last time, actually the diagram has three parts. This one negative, that one positive, this one again negative. Okay, so I can calculate free haul and overhaul here, I can calculate free haul and overhaul here, but I will not do it here because it's only 2-3 stations. Okay, so there is no overhaul here. He's already agreed 500 feet free, right? So it's 300 feet, he will not ask for anything. Okay, so first thing I need to know is what is the ordinate at station I'm still looking for that girl who went in that direction. She is not there. Okay. What is that? Yeah. I need the quantity of material at these stations. Okay. One of the stations is 1120. The other one should be 500 feet from it, right? Because he agreed for 500 feet. So 1120 plus 500 is 1620. Okay. So I need to get the ordinate at both the stations. I need to get the ordinate at both the stations. Now, I'll go to the table. This is my table. Okay, so I'm looking between 16 and 17, right? I'm looking between 16 and 17. Okay, I have the value for 16, I have the value for 17 as well. These two values. Okay, it was no 1120, right? I'll start from 1120. Now I look for a value between these two for 1120. I have the value for 11 and 12, 201 and 638. So 11, 201, 12, 638. Give me the value for 1120.
Actually, 11 is 600.
Sorry?
11 is 638.
638. And what they write? Huh?
For 11, it's 600.
For 11 is 600? Yes. Thank you. You should come in every class. 900 what? 4. Okay. Huh?
691.
Huh?
691.
Okay. 500 feet from this one. These are the two balance points, right? So I need the ordinate here and I need it here as well. How much it should be without any calculation. How much it should be. These are balance points. They are balance points. So it must be what?
6
Same. Right? It must be same, right? The ordinate must be same because they are in the same line. I'm talking about this one. On the top, S and T. The Y value should be same, right? Okay, should be. Okay. $16.20. 16, I have 732 and 303. Okay. I'm looking for a value of 691. Will I get it? You interpolate between these two values, 732 and 303. Okay. Maybe you will get 691. How much you are getting? So 16 is 732 and 17 is 303. How much for this?
646.2.
Point.
2.
Okay, now these values tell me what? That my line is not straight, right? Going like this, but the diagram doesn't show this. Okay, what's the reason? I mentioned it last time as well. Why the numbers from the table, I'm calculating the numbers from the table and they are not giving me the same answer. The figure should be same. What could be the reason? Yes, good. We connected the points by hand, okay, or we let the software do it, okay, whatever the reason is. But between the 2 points, the software is working by itself, freehand, okay, it's not following any curve, okay, it's not following any curve. So if you calculated point after every 1 feet and then you plotted it, that will become more accurate. Okay, but we didn't do it. Between each 2 points, we have a gap of 100 feet, right? 100 feet is a lot. Okay, you can go in any direction. You can make the curve like this. You can make the curve like this as well. Okay, so this is because of how you join the points or how the software joined between two points. Okay, clear? You get the point? What the issue is? Okay. Now to solve this issue, there are 2 methods. To solve this, I cannot work like this, right? It's not balanced now. Okay, I cannot calculate my quantity when the line is actually not balanced. So I have to assume it is balanced and do some adjustment. Okay, in the end, I will not take 2 different quantities because the contractor will say, what are you doing? These quantities must be equal. Got it? So there are 2 ways to do it. One is the graph is showing a straight line, right? The graph is showing a straight line between J and K. So you go to the graph and find out the Y value at J and K. It will be same, right? Because it's a straight line. Okay? There? Whatever the graph is showing, whether it is matching or not matching, not my problem. Okay? Clear? Any problems? So this is one method of doing it. Secondly, let's say you have a graph like this. You don't see any grid lines. There is no scale. Okay? When I copied the figure, maybe I made it more longer or bigger. Maybe I made it smaller. Okay? So I may have disturbed the scale as well, right? Okay? So what is the other method? You take the average of these 2 values. And that will become your balance coordinate. Okay? So one is what they are showing there, 675. How did they get 675? They took the exact value from the graph. They forgot about the table. There is no table. There is only this graph. Okay, and this is the value exactly at J and K. Exactly on the graph. This is my value. Whatever the software did, whatever happened between the 2 points, I am not concerned. Got it? Clear? This is one way of doing it from the graph. The other way, if you believe the table, then you will take the average between these 2, and that will become your final value. Okay? So either you can take 675 or you can take average of these 2 values. Okay, both methods are correct. No, there is no problem with that. Okay, but this one will only be applied if you have the graph from where you can pick the value. Okay, got it? Okay. Now we will go with this value. Okay, so we know the ordinate. Okay, but the total ordinate is not enough. It's 675 at the end, right? This is 675 at the end. Okay, so he is not transferring all the material at the end. He is taking it from different stations, right? Okay, so now we will calculate what they call as moment of material quantity. Okay, the moment of material estimation or whatever you call it. Okay, now when you calculate moment, you do moment in a sequence, right? Okay, moment is what? It's a product, right? Product of what? Moment is a product of distance and force. In this case, the moment of material, distance and material. Okay, it's a moment between distance and material. So you will take the distance, multiply by the material. Okay, you take the distance, multiply by the material between every two stations. Between every two stations. Okay, so first of all, I'll start from point D dash. It's a balance point, the 0 point. Okay, I'll always start from the 0 point. Okay, now after 960, the next station is what?
11:40.
No, next station 10, right? Okay, so I will take the mid of these two. Okay, the distance will be taken from the mid. Okay, so 960 and 10, the mid will be 980, right? Okay, so 960 their mid. Okay, up to which station? 1120, right? I'm going up to 1120, right? So my distance is 1120 minus this. Okay, this is my distance. Okay, and the material I will transfer between these two stations. At station D dash, material is 0. Okay, at station 10, the material is 201. So this whole thing will be multiplied by 201. It's a difference of 0 and 201. Okay, so the answer is 201. Okay, the actual is 201 minus 0. Okay, the actual is 201 minus 0. Okay, then so I'm at station 10. From station 10, I will go to station 11. Okay, so now the difference, I will take the mid of 10 and 11. Okay, the mid of 10 and 11, and I'm going up to again 1120. The mid of 10 and 11 will be 1050, right? And this multiplied by the ordinate between them, which is 638 minus 201. Okay, so I reached up to station 11 now. After 11, from 12, 1120, I am taking from the mid. Okay, so 1120 minus mid of 1120 and 1110, right? Mid of 1120 and 11 is 1110. Multiply by the difference of ordinate, which is, where is it? No, at 1120 675, right? It was 675. At 11 it is 638. Now remember, the contractor was charging per cubic yard per unit distance. He was charging per cubic yard per unit distance. Okay, the cubic yard I took from the graph. Remember, at 1120, 675. Okay, I'm doing this to calculate the distance. So first of all, what is the answer of all this? The total.
998.
998. Okay. This is 998 cubic yards. Uh, you are keeping this what? 11 plus 11.1.
Yes.
11.1. So, okay, this is cubic yard stations. Okay, I don't want cubic yards, I want this stations. Okay, so I will divide it with the total material I have. So 998 divided by, we can do it from here as well. I believe you should keep the same answer. Yeah. So 998 divided by 675. How much? 675.
147. 147. 1.47.
1.47. 147. 1.47.
1.47.
1.47. Or, and if you divide by the summation of these three, what happens? There should be some change. So this divided by this 201 plus this plus this. There is a small change I believe.
It would be less than 1. It would be less than 1.
It will be less than 1.
1.7.
Same answer.
Same answer.
Okay. Same answer? Okay, good. So 998 divided by 675, the material we already know. So we got 1.47 or 147 feet. 1.47 stations or 147 feet. Okay. The same will be repeated for the other side as well, on the side of K. Oh, sorry, S and T, right? So same will be repeated on this side as well. Okay. Again, I will go back to the table. So the other side, I'm at station 1620. Okay. After 1620, the next one is 17, right? Okay. So I will take 1620. Minus the mid of 1620 and 17. How much? 1660, right? 1660. Okay, the midpoint, like we have been doing. This multiplied by the difference of ordinate. At 1620, it is 675. Okay, and at 17, it is 303.
Yes.
303, right? Okay. Now the next point is at 0. Point E dash. Okay, so after 17, I will not go to 18 because 18 is on the other side. Okay, it's after the balance point. So I'll go only to 1763. Okay, so I'll now take the midpoint of this one. So this will give you negative, right? I should do the other way around because we are going in this direction. Okay, the distance cannot be negative, obviously. So 1660. Okay, just to keep the distance positive, cannot make it negative. Okay, so where am I going? I'm going to 1763. So between 17 and 63, what's the midpoint? Half of 63 is what? Half of 63 is 32, right? Almost.
That's 1.5.
Huh?
That's 1.5. So
32. So at E dash it is 0, at 17 it is 303. I should subtract
675 minus
675 minus at 1620 it is 675, at 1660 it is at 70 it is 303. Okay, so this is the distance from the mid to my ballast point. Okay, and this is the material between the 2 points, between 1620 and 17. This is the mid from 17 to 1763, and this is the material. Okay, so at 17 it is 303, at 1763 it is 0. So 303 minus 0. Okay, how much you got?
488.
488. Again, cubic yards, stations. I divide by 675. Again, how much?
0.723.
Stations. Okay. So I have total material 675. So now I am calculating the overhaul payment. The material is 675. But I'll start with the rate. The rate is $11. $11 multiplied by 675 cubic yards multiplied by stations. From this side, 0.72 stations. Plus again $11 multiplied by same quantity, it's balance, multiplied by the stations from the other side. Okay? Clear?
Can we request?
Which one?
All things.
Hmm?
All things in place.
Okay.
Can we request?
Which one? This one. 11 is per cubic yard per station. I'll take 11, multiply by the material, multiply by the number of stations. Okay? The material from the graph. Stations, we did this to calculate the stations. Okay? Now your problem must be here, right? Okay. To calculate the distance, okay, if I just take the distance from the midpoint, I'm assuming that from start to end I have the same rate of material, but it's not correct. Okay, I may have more material between two stations and I may have less material between the other two stations, right? So I will not take the distance as the midpoint of the total. Okay, so this is the method to calculate the weighted average of the distance, not the average distance, but the weighted average of the distance. So I'm taking the distance and multiplying with the material in that distance. Okay, so if the material is more in this much distance, its weight is higher. Got it? Clear? Okay. So when I do this, I get the answer cubic yards and stations both. Okay. This is summation. You can see there is no average here. There is no average. I just added, right? This plus this. This is only addition. Okay. To get the average, I must divide by the total, right? I must divide by the total. Okay. So what is my total material? Okay. Clear? So this distance is what we call as weighted average distance, or the method is called as the movement method, because you are multiplying the distance with the material required in that distance. Okay, and why are we doing this? Because between 2 points, the amount of material can be very high or very low. So if you take just the midpoint and you calculate everything from the total midpoint, then you are assuming that between each 2 points I have the same amount of material. But you can see it's not the same, right? Between these two I have 303. Between these two I have more than 303, right? Okay, so the material is not the same. If you come here, this is 201. This is more than 400, right? And this is very small. Okay, So that's why if you just take the midpoint and multiply the material with this distance from the midpoint, your assumption is from start to end the rate of material is same. Okay, which is not the case. So that's why we are applying this method where we take the material, multiply with the distance from the mid. Okay, so when the material is higher, the distance has more weightage because you are multiplying it. Okay, divide by the total to make it average. Got it? Clear?
Can we
Now you will ask questions as well.
can we multiply 488 times by the price of rate to get more?
Multiply what?
488.
I think so, but they are not doing this in the. I think so. You can do it. Should work. Because you are dividing it with 675 and multiplying it again with 675. Should work. But I don't know. For some reason they are not doing it. It's an acceptable.
What is the question? Like this question we define that?
Inshallah. The Bahraini issue. Okay, any more questions? Apart from will this come in the final round? Okay. The reason I was late was because of what I was trying to do with the software. I told you about the software. I still have the software. I have it in the other PC. Okay, I was trying to install it in this one, but I was facing problems. So what we will do, I will give you the software, and in the next lecture I will bring that PC. Okay, but for the time being we will do something which could be important for your term projects. That is the estimation for the stairs. Where is it? Where did I put it? Okay, I could not find any clean examples in the books which follow the method which we are following with the NRM and everything. I found this online. It's clean enough. I have the other book which I keep on mentioning, the book from Datta. Okay, they have they have another example, but they are using Indian terms and so on and so forth. So like, I have enough problems with you and Arabic. So like, I don't want to increase my problems. So we'll go through it. You take the software from me. You come back with it next time installed. Okay, bring the other PC. We can go through some exercises for the software, so you will have an idea. Okay. A staircase, it provides you access to different floors in the same building, as we know. Okay, there are these components to the staircase. Okay, so you must keep them in mind so that we don't miss. We keep on saying this. You must make a list before you start doing the takeoff, before you start doing the measurements. So the list will help you see if you are covering everything or not. Okay, so you must know the components of the stairs. So the first one is the waist slab, which is the inclined slab, the one under the steps. Okay, that is called as the waist slab. Okay, and then we have the flight, which is the steps itself. Okay, so the steps are called as flight, and under the steps we have the waist slab. Okay, and then we have the landing. Landing is at the end of the stairs. Okay, so when you go up, so there is a resting area, right? There is a straight area, then you go the other direction. Okay, so this is called as the landing slab. Okay, this is a landing slab, and then we have the steps, as I mentioned. A step consists of two parts. One is called as a tread, the other one is called as a riser. So tread and riser are the parts of the steps. Okay, tread is the horizontal part and riser is the vertical part. Okay, so this surface is called as tread and this surface is called as riser. Okay, so we have the waist slab, we have the landing slab, we have the steps, and the steps combined are called flight. Okay, the series of steps called flight, and then each step consists of horizontal part, which is tread, and the vertical part, which is riser. And you can see all of them. They are mentioned here. I'll upload it. Okay. So on the steps, sometimes you see these, handrails or supports at the sides. Okay. So they are called as handrails. You can have some beam here for supporting the slab. That is also called the handrail beam. Okay. And as you know, the steps go like this. You come here, you will have one landing slab. Then you go up, you will have another landing slab. So usually between two floors, we have two landing slabs. Okay, one at the mid, the other one as a full height. Okay. Till the start of this year, I was living in a building which had only one landing. Okay, so you start from the ground floor up to the first floor is straight up. Okay. So and when we shifted, they had a problem with the elevator. So you go over this thing, you start having your brain starts to go around. Okay, it looks like you're going on a mountain. Okay, because of this. So that's why we need the two landings there. The slabs are usually reinforced. The slabs are usually reinforced. How many slabs we have? How many slabs we have? Yeah. Two. Which ones? You are going to say this one and this one, right?
Two is the slab and two for landing.
Yeah, like two types of slabs, one for the waist and one for the landing. Yeah, the slab, this one. So this slab will be connected with the landing slab. Okay, the base slab on the upside will be connected with the landing slab, and this one again with the landing slab, and somewhere up on the top it must be connected with the other slab as well. Okay, so the base slab is connected at both ends. What about on the downside? Okay, so I'm at the ground floor and this is my first flight. So this is my first waist slab. So on the top it will be connected with the landing. At the bottom I may have a wall. Okay, so I will connect it with the beam under the wall, the wall beam. Okay, we have seen them in the substructure. Under the wall we put the beam as well. Okay, so you connect the base slab with the beam. Okay, so the point is the landing slab, no, not the landing, the base slab must be connected. Okay, some of the things which are given in the figure, the numbers are mentioned. That's why I said it's very clean figure, and I mess it up for the exam. But the main point is, if you want the now you look at this 3 meters. Okay, so or you look, go at the top. So you see this 3 meters, which is the length of the staircase. Okay. This is the straight length, but your base slab is not straight. So 3 meters like this. Okay, but the base slab is like this. Okay, so the first thing you need to do is calculate this length. Okay, so how do I calculate this length? Pythagoras theorem, right? Okay, so in this case it will be the square root of 3 square plus what? The height. And the height is given in the other drawing. Total height is 3 meters. 1.5. Okay, till the mid. Okay, so I believe it will come out to be somewhere around 3.35 meters. So the first thing, whenever you have this thing, you need to calculate the inclined length of the base slab. Okay. Yeah. Okay. Now the bars. Okay. So this is the base slab, and this is the landing. Okay. So in the base slab or any slab, If you have seen the slabs for your term projects, you will see the bars are given in both directions. Okay, they are going in this way as well as this way. Okay, same thing happens with the footing as well. Any element which is horizontal in the structure, you will see reinforcement going in both directions. Okay, so we have the X bar and we have the Y bar. This is only for this example. Okay, you can name it anything. Okay, X bar because they are showing it horizontal, the Y bar because they are showing it vertical. Okay, the X bar, this is the plinth beam at the down level, and then this is the landing at the top. So the X bar should go into the beam and it should go into the landing, okay, on the top. And the Y bars, they go like this. It's not shown here. They are trying to show something like this, okay. But basically at the end of the slab there is a beam. Okay, so these bars are going into this beam. Okay, how do I show it? So this is my base slab. Okay, and there's a beam here. Okay, so these bars, they are going from the base slab into the beam. Okay, they are going into the beam. And how much they are going? 50 times of dia. D means the dia. Clear? Okay. For all of them, I believe where is it? Yeah. For all of them, they are saying the dia is 8 millimeters and the spacing is 100 millimeters. All of them. Okay. And they are saying the concrete cover is also 0.1. The concrete cover is also 0.100 millimeters in this case. Okay. For whatever reason. It's a value. Okay. There is no calculation here. So concrete cover is 0.1. The overlapping of Y bars into the beam is 50 times dia, and the hook is 9 times dia. This hook. There is no hook on that side. There is only hook here. Okay. And in the next figure, it will be shown why it is only on this side.
Only on the beam.
Only on the beam. Yeah. So the hook is like this. Because in the beam we have a ring, right? So they made the hook into the ring. Okay, to connect. Okay. Now, how much is this extra length? So up till here is the slab, right? Up till here is the slab. After that, this is the ring of the beam, plinth beam. How much is this distance? Between the yes, cover, right? Between the concrete face and the reinforcement, concrete cover, right? So this much is the slab, then concrete cover, then the hook. Clear? Slab plus concrete cover, then the hook. Okay, the hook is 9 times of dia. Concrete cover in this case is 0.1. And for the landing, this thing, how much it is going into the landing? Full. Okay, the overlapping of the base slab reinforcement into the landing is full. Full up to what? Full means like it will go the other side. So this is my landing slab. So it will go complete to the other side.
Full without the cover.
Full without the cover. Okay. So for the landing slab overlapping, you will just subtract the cover. That's it. Clear? Okay. Okay. So we are doing it for the first base slab. Okay. What was 3.35? The slab. Okay. Now we are doing the X bar, the horizontal bar, which are going from the landing till the plinth beam. Okay. So 3.35 the slab. Okay. Plus 1.15 is the other side. This one. The landing. Yeah. The landing. This one. Okay, so full landing minus the cover. Full landing minus the cover. Okay, cover minus cover, remaining is 1.15. The full landing was something something minus the cover, you get 1.15. Okay, clear? Okay, so 3.35 waist slab, 1.15 overlap into the landing. Okay, plus concrete cover for the plinth beam, plus 9 times dia the hook in the plinth beam. Okay, so this will give you the total length, which is 4.672 meters. Okay, then the Y bar. Okay, this is much easier. 1.2 is the total width of one slab. Okay, one part of the 1.2. Okay, full waist slab, right? Full waist slab. Okay, plus it will go into the beam, the handrail beam overlapping. Okay, which is 50 times dia.
2 times
2 times 50 because from both sides. Okay, so 50 times dia both sides. There's a beam on this side, there's a beam on this side. Okay, so the base slab plus overlap into the beam, overlap into the beam. Clear? Okay, so we got 2 meter full length here. And how do you find out the number of bars?
Then divided by spacing plus 1.
Length divided by spacing plus 1. Yes. Okay, so for x bar, okay, if I'm talking about these bars, my spacing is this one, right? My spacing is this one, which is 1 point. Okay, and if I'm talking about the y bars, my spacing is this one, 3 point something something. Got it? Okay, for both of them, sorry, I was saying spacing, the length. For x bars, the length is this much, 1.2. The y bars, the length is this much, 3 point something. Okay, and for each case, the spacing is same, 100 millimeters. Okay, so one time you will do for this one, divide by 100, and then this one divide by 100, both plus 1, which is what they are doing here. Okay, so when you are calculating the length, you have to keep in mind that you do not take the spacing which is going into the landing. The spacing is within the waist slab, not in the landing. Okay, so this is not part of spacing. Spacing is in the slab itself. Okay, minus the cover. Minus the cover. Okay, so this is okay for the x bar and for the y bars. Sorry. Yeah, they are taking half of the cover. Did they include yeah, so 0.05 is the cover, because if you see on the top, they are only taking cover from no, I don't know why. They are taking different covers for slab and beam. So in beam they took the cover 1.1, for the slab they are taking the cover 50 millimeters, which makes sense, because beam is thick and slab is usually thin, so that's why you can have less cover. If you go into the examples which we did, you will see we were also taking different values for the cover for different items, because for beams it's normally 25 millimeters for beams and these things. Okay, if you want you can take it same, but you read the specifications, maybe it's written there. Okay, one of the sections, maybe it's already mentioned. Must be written. If it's not written, you come and ask Mahdi, right?
Yeah.
Yes, you take his number. Okay, once you find out the length of the bars, okay, so you found the length of each bar, multiply with the number, and since both of them are of the same die, you can add them together. Okay, so I can do 4.672 multiplied by this thing 1.1. No, sorry. Where is the number of bars? Number is not mentioned. Okay, you mentioned it yourself. 12 bars. Okay, so 4.672 multiplied by 12 bars. Okay, this is for the x direction. For the y direction, 2 multiplied by it's not mentioned, but it will be 3.25 divided by 100 plus 1. How much is it? 3.25 plus 1. How much? 34. Okay, so 34 multiplied by the length of one bar, which was 2. Okay, so you can add them all together because they are of the same dia. So 34 into 2 for the y bars, total length. For the x bars, we have 12 bars multiplied by 4.672. And then you can add them together. This will give you total length. Okay, and because the dia is same, so I will just do d square upon 162, which will give me 0.39 kilogram per meter. Same dia, so the same will be multiplied by both of them. Okay, that's why I'm saying you can add them together. Okay, so they added them together, they got 56. No, sorry, for x they got 56. For x they got 56. Okay, for y they got how much? 78. Okay, so this 32 into 34 into 2 is 78, right? Oh no, it's not 78. Huh? 68, right? So there is a problem there. Yeah. Okay. So it must be 68. This must be 68. Okay? Clear? Clear? This must be 68. You can say 56 as well. Maybe it's also wrong. Okay. Then we don't have, this is for the first waist slab. From ground to the middle, then from middle to the top. Okay, the second waist slab. And why we are doing it differently? Because for the first waist slab you had the connection with the plinth beam. For the second one you have the connection with the two landings, so their calculation will be different. Okay, if they were same I can just multiply by 2, but I cannot do it like this. Okay, but you can see the dimensions are same. Okay, now in the first case I was doing length of the slab plus concrete cover plus hook, right? But now it's easier. Whatever I did here, multiply by 2. Okay, so if this is 1.15, then this is also 1.15. Clear? Okay, and for the y, no change. You can take the same length. It was 2, right? You can take 2. 1.2, yes. So for the y direction, you can take the same. Okay, even the spacing is also same, right? Spacing is also same. So you will get same number. For the y direction, you get the same number. Only for the x direction, you will have the change. Okay, and the change is because of the connection with the landing slab. Clear? Okay. As you can see over here. For the x bar, one landing, the other landing. Okay, for the y bar, same as before, the length is same. Number of bars, again, for the x bar and the y bar, you get the same numbers, obviously. Because the length of the slab has not changed. Okay, it's still taking 78 again. Okay. Okay. Now for the landing, the reinforcement from the base slab is going into the landing, right? Okay. So in the X direction, you already have the reinforcement coming from the base slab. Okay. This one is going in, right? So I don't need any other reinforcement in this part of the slab. I will need one in the Y direction, right? For both landing slabs, I need the reinforcement in the Y direction. Clear or not? Okay. Now what is the dimension in the Y direction? 2.5. The landing slab 1.2 from here, 1.2 from here, plus little bit extension on both sides, or maybe some gap between the two flights. Okay. So total is 2.5. Okay. 1.2 one side, right? 1.2 plus 1.2, how much? 2.4. Okay. And maybe there's some gap between the two sprites, because you have one flight and you have the other flight, right? So there's some gap between them usually, right? Okay. So this gap added, you get total 2.5. Okay. So 2.5 is the length minus what? Minus cover. Okay. So for the Y direction in the landing slab, you just subtract the cover. So 2.5 total minus cover from both sides. You want number of bars. So it was total 1.2 minus cover, remaining 1.1, divide by spacing plus 1. Okay. And the total length of the Y bar equals to this, and so on. Clear? Okay. Now tell me this. What happened to this one? What happened to this side? It's without reinforcement. I keep it without reinforcement.
2.5 minus this part.
For the Y direction, I took total length, right? 2.5 total from top to bottom. Now the horizontal one, the X1, is coming from the base slab, right? So it's only coming in half of the landing. Agreed? All of you agree?
2.5 minus.
I did not finish. Everybody is 2.5. 2.5 minus something. Let us do it quickly. No, we don't have to do it. I know you guys will do it in the exam as well. Okay. You are also doing it? MashaAllah. No? She's saying I didn't do anything in the whole class. Why will I do it now? Okay. Now remember, there are two base slabs. This is only showing because this is the plan view at the upper level. Okay. So there's a slab at the bottom as well. You cannot see it. Okay. But the bottom slab will have reinforcement going in this one. Okay. So the other half is covered by the other base slab. Every landing has two base slabs, right? Every landing has two base slabs. The stairs go like this, right? So half of the landing is covered by this one, the other half is covered by this one. When you look at the plan view, it's only showing from the top, so you cannot see this one from the top. Okay, that's why you see half of the portion it's not empty. It's covered by the other base slab. Okay, clear? Let us do 2.5 minus something. Okay. Okay, this is for the steps now. How much time we have? 10 minutes. Okay. Okay, we'll keep it next time.